Hello, this is 9.5, the reciprocal trigonometric functions. Are you having fun with trig yet? I hope you're not afraid. It's really not bad, it's just you have to adjust to it. Now some of you have met these already because I accidentally gave you them on your Math Excel homework. Okay, so first up we're going to talk about secant. It is pretty straightforward. It is just the reciprocal of cosine. So, a couple things we need to think about, and that is what angles can we not have secant for? That would be any angle that has a cosine of 0. So if you come over here, you'll notice I've already drawn a unit circle. And remembering that cosine is the x value, this is where the trouble is. So basically, if I go to 90, I'm finding trouble. Come around 180, I'm up at 270, I got trouble. And every time I kind of keep looping back 180 degrees, I get to that same trouble zone. So the way we write this is we say that theta cannot be 90, because that's where the first trouble occurs, plus any multiple of 180. Because every time I add 180 times 1 is 180, or 180 times 2 is 360. I keep coming back to that trouble. And just to be clear, I'm using n as an integer. Now, something we haven't really talked about lately, this really is the domain. Okay, I'm going to briefly try to get you to understand what the values are for seek. I'm going to try to show you so you understand, but if you don't, in the end, you just really need to know what possible seek values are. So I'm going to start with cosine, and hopefully you have some sense now that cosine hangs out between -1 and 1. And this hopefully would make sense to you, because if you think about cosine, like if we start here, standard position, out here cosine, remember, is the x value, so this has an x value of 1. But as I keep moving this direction, my x value keeps getting smaller till it gets to 0. And then my x value goes negative until it gets to -1, and then it starts coming back up again till it gets to 0, and then it finds its way back to 1 again. So those are the types of values we would be expecting for cosine. So in the end then, secant is really the values that we get when we flip those values of cosine. So when we flip a 1, we get 1. When we flip a -1, -1 over 1 flipped is -1. The question is, what happens to all these fractions? Because hopefully that's what you realize is between 1 and -1 when we flip them. So say like 2/3, for instance. Well, when you flip 2 over 3, you get 3 over 2. So this guy that's a fraction with a numerator smaller than the denominator is always going to end up then with a numerator bigger than the denominator, which is always going to be bigger than 1, or less than -1, if it happens to be a negative number. So in the end then, if someone's asking you, well, what kind of values do you get for secant? Secant is always going to be greater than or equal to 1, or it's going to be less than or equal to -1. And this is what we would call the range, because these are the values that come out when we put angles in. Okay, there you have it, your first one. Cosecant function. So the cosecant of theta is 1 over sine theta. And yes, you probably are just plain going to have to memorize these. We'll summarize these in a minute so we can see if we see kind of a pattern. So same idea. Where do we have trouble? Well, we have trouble when the sine is 0. And if you recall, sine corresponds to the y value, so these are the places where we have trouble. So at 0, right off the bat, we can't have a cosecant because the sine is 0. And then the next time we have trouble is when we get over here to 180. And then anytime we come 180 around from here, we're going to keep running into that same problem. So the way we would describe this is that theta can never equal 180n. Same idea where n is an integer. So this then really is your domain. Okay, so cosecant and sine are reciprocals. If you know what the sine is and you want the reciprocal, or you want the cosecant, just flip it and you'll get the cosecant. If you know the cosecant and you want the sine, just flip it and you'll get the sine. So, sine theta hangs out, the values hang out between -1 and 1. Same idea as what I talked about for cosine, but remember, sine is the y value, so the highest y value it gets to is up here, and the lowest y value it gets to here. So the highest it goes is 1, and the lowest it goes is -1. So for the exact same reasons I said for secant, I'm going to say the same thing for cosecant. So basically, the cosecant is going to be greater than or equal to 1, or it's going to be less than or equal to -1. 2 down, 1 to go. Okay, cotangent is a little bit more complex to think about, and it gives us a chance to think about tangent a little more maybe than we've already talked about. And I know this is like new and maybe a struggle in some respects, but just hang on there and see if you can kind of understand what's going on. We have seen that tangent of theta is equal to sine of theta over the cosine of theta. So basically, tangent has its own little issues, and its issues are that anytime the cosine is 0, the x value is 0, tangent does not exist. So up here at 90 degrees, tangent is undefined. Because when I do sine over cosine, I'm really doing 1 divided by 0, and that's undefined. When I come down here, I have the same problem, because when I put -1 over a 0, once again, I have that issue. So here, tangent is also undefined. Now, in these two positions, sine over cosine, y over x, tangent is going to be equal to 0. Over here, same thing. When I do the y value over the x value, I have my tangent equal to 0. So now, applying this to cotan, which is the reciprocal, as in flipping these guys, the cotan of theta is going to be equal to 0, believe it or not. Remember, I'm going to flip this. I mean, technically, the cotan of theta is the cos of theta over the sine of theta. And just sort of hang on for the ride if you're kind of your head spinning here. But so the cotangent of theta is the opposite. Instead of 1 over 0, it's going to be 0 over 1. So tangent's undefined here, but the cotan, when I flip that, is going to be 0. So the cotangent of theta is going to equal 0 when tan is undefined. And even if you can just sort of start kind of feeling this a little, that is a good step. Okay, now, when tangent is equal to 0, so this would be like 0 over -1 or 0 over 1. Imagine flipping that. Well, guess what happens? When we flip 0 over 1, we get 1 over 0, which is undefined. So, theta cannot equal 180n, because that is going to be causing it to be undefined, which is going to be going on at this place and this place. So there you go. Tangent's a little bit different. As far as what comes out of cotangent, what comes out of tangent is all reals, and so the values for cotangent of theta is also going to be all reals, the range. And we'll probably talk about that a little more in class. I don't want to get too involved in that right now. You hopefully will have talked about it a little bit in class before you watch this lovely video about reciprocal functions. Okay, the other thing I want to just say is that for all of these, if you have a positive sign, then the cosecant will be positive. If it's a negative sign, the cosecant would be negative, and this is going to be true for cosine and secant and tangent and cotangent. So let's just do a quick review here. The sec of theta is equal to 1 over cos theta. The cosec of theta is equal to 1 over sine theta. And the cotangent of theta is equal to 1 over tan theta. Personally, the way I remember these guys, these reciprocal functions, is this guy has an S, and it's going to go not with an S but with a C. This guy has a C, it's going to not go with a C, that might be more convenient, it's going to go with an S. And then cotan and tan just go together. They just sort of sound like they go together. Okay, so let's just go back into the old triangle for a second and kind of add this new thing that we're into here. I've just drawn a right triangle, we'll call it triangle ABC. I'm using caps for my angles, so the side across from, like an angle A, I'm calling little a, across from angle B is little b, big C, little c. So every one of these is written in terms of angle A. So I'm going to go ahead and label up my triangle. This would be my hypotenuse. This guy over here is going to be called the opposite, and this guy is the adjacent. So just to review, sine, cosine, tangent. So, ka, toa. So, guess what? If I come over here then, instead of O over H, sine and cosecant are reciprocal. This is H over O. Cosine and secant, reciprocal. So this is H over A. And then tan and cotan are reciprocal. So this is A over O. So we can work with these these three additional trig functions in triangles also. So if I just was going to fill in the blanks here quick. So in sine of A would be A over C. Cosine of A would be B over C, and tangent of A would be A over B. And then these are all just going to be the flip. Okay, a couple problems, and this one is going to kind of get back to what was on the MathXL already, where it asked for all 6 trig functions instead of just the couple that I wanted you to do to begin with. So, and this is kind of a question regions people like to ask. So, terminal side angle theta in standard position intersects the unit circle at 5/7, negative 2 radical 6 over 7. Find all 6 trig functions in simplest radical form. So, personally, for me, I like to set myself up with something that feels comfortable. So I'm going to go ahead and I guess I'll just do it the way I usually think if I look at my calculator. The sine of theta, the cos of theta, give myself a little more space here, and the tangent of theta. Now, these two guys are easy, because as long as I'm straight on which is which when I look at this point, because I know it's on my unit circle, this is my cosine, because it's in my x position, so I know the cos is 5/7. And then this guy right here is my sine, because that's in the y position, so that's negative 2 radical 6 over 7. Now, I'm going to go ahead and I'm going to set up my reciprocal trig function. So this guy is an s, the sine of theta, so cosec theta is its reciprocal. This guy has a c, so its reciprocal is the secant of theta. And tangent, just realize its reciprocal is the cotangent of theta. Now, if I wanted to just kind of get myself rolling here and feel good about myself, I see that 5/7 and say, ooh, I just think I'll just flip that. 7/5, done. Now I'm halfway there. Now, since I already have this guy, I'm going to come over here and I'm going to say, well, cosecant, that's not bad. And remember, whatever, if this is negative, it's going to have a negative reciprocal. So this is going to be negative 7 over 2 radical 6. Now, because this says simplest radical form, I am going to clear that radical in the denominator. So instead I'm going to have negative 7 radical 6 all over square root of something times square root of something is a something. So radical 6 times radical 6 is 6, and 6 times 2 is 12. Okay, I'm 2/3 of the way there. So I've got sine theta, I've got cosine theta, I've got cosec theta over here. Don't forget that little negative sign, and I've got my sec. Okay, a little bit more work, but we're very close. So the tangent of theta is the sine of theta over the cosine of theta, which is going to get a little ugly here for a minute. Negative 2 radical 6 over 7 all over 5 over 7. So I'm going to, and you sort of have no choice but to deal with fractions here, I'm going to keep my numerator, change from division to multiplication, and flip my denominator. These 7's are out of there, and in the end I get negative 2 radical 6 over 5. So that is my tangent. And now we just have one more. So I'm going to cruise on up here, and I'm going to say all I got to do to get cotan, I realize it's going to also be negative because it's going to have the same sign. So negative 5 over 2 radical 6, and I'm going to go ahead and clear my radical in the denominator by multiplying by radical 6 over radical 6. And I get negative 5 radical 6 all over. Square root of 6 times square root of 6 is 6, and 2 times 6 is 12. So there you have it. There is the cotangent. So that right there is what on Math Excel for schools they were looking to have you do. And that's the practice I'm going to give you tonight, now that you have the skills to do them all. Okay, one last problem that you sometimes get now that you know so many things. You may be asked to actually, because you know some relationships now, show that the tangent of theta times cosec theta does actually equal sec theta. So what this really is about is starting to think to yourself, well, what do I know about tangent of theta? Well, we know, hopefully, that the sine of theta over the cos of theta is the same as the tangent of theta. And so now we realize, hopefully then, that cosec theta is the same as 1 over sine theta. So I'm kind of doing a little mini kind of informal proof here. So I still don't have these both saying sec theta. So now sine theta and sine theta can go away. So now I have the 1 over cos theta. Does that equal sec theta? And now, due to what we've just talked about, these guys are reciprocals. 1 over cos definitely is sec. So yeah, I can show the world that, yep, that relationship is true. Okay, now you should head on over to Math Excel for Schools and do the homework, which is going to look like what I've given you previously, but now you've got the tools to do it.